Hey guys, welcome back. This is going to be the video for day 4 of our e-learning into chapter 8. Our goal for today is to talk about how we can describe a graph even further just by looking at the equation of a polynomial, whether it's in standard or factored form. So we're going to talk about how to do that, and specifically the characteristic of the graph that we're going to talk about today is something called end behavior. So we'll be talking about that extensively here. Okay, so let's go ahead and get started on a problem and see what we're dealing with. And we're gonna, before we talk about end behavior, we're just gonna kind of do some of the stuff that we've been doing already, and I'll kind of demonstrate where the end behavior plays into this thing. Okay, so let's take a look at this first polynomial. We have a polynomial that's in factored form. We've got parentheses here being multiplied x minus 2 and an x plus 1. Don't forget from the last lesson, we kind of talked about this situation where we have a factor that's being raised to a power. So this x plus 1 is being raised to a power of 2. So really, even though we don't see it, there's 2 x plus 1s here. So there's 3 factors. Okay, and what that tells us is we have 3 factors with an x in it. So we have a degree of 3. And I'm just going to write that off in the corner here, but notice what they're paying attention to. They don't really care what the degree is for this kind of problem. They're concerned about whether or not it's even or odd. So 3 is an odd number, so I'm just going to put here that we have an odd polynomial. That's what it means for a polynomial to be odd. Okay. This first column, what they're asking for, you'll see this LC, they're talking about a leading coefficient, okay? So LC stands for leading coefficient, and we can see the leading coefficient in a factored polynomial by looking at the number out front, and you'll notice that there is nothing there, so we get to assume that it's a 1, and so I'll write the 1 up here in the upper left-hand corner, but we're not really concerned about what the actual leading coefficient is. We're concerned about whether or not it's negative or positive, okay? So the 1 is a positive in this case. So the polynomial we're dealing with is a positive odd polynomial. Okay, so what does that mean for this thing, end behavior? What is end behavior exactly? All right, so to demonstrate end behavior for you, we need to look at the graph, and I'll show you where we see this thing called end behavior. So I use Desmos for graphing. You can use your graphing calculator, or you can open up Desmos on your Chromebook and graph this thing so you can see what I'm seeing here. All right, so I'm going to go and let's take a look at, this is our polynomial x minus 2, x plus 1 squared, right? Yep, x minus 2, x plus 1 squared. So same thing, and you can see it graphed right here, so we can see the shape of this thing, and I'm going to get a quick sketch of this on my notes. Okay, so just, you want to kind of mimic this shape. Doesn't have to be super accurate or anything. We just want to make sure we get the x-intercepts in the right place and the general shape of the polynomial. Okay, so since we had a factor of x minus 2, I know I'm going to have an x-intercept at positive 2. And then here we had a factor of x plus 1, so I know I'm going to have an x-intercept at negative 1. So I'm going to plot those 2 points, and then I'm just going to get the general shape down here. So this polynomial started down here like that, and then it kind of came up here and hit this x-intercept and then went back down. And then it eventually has to come back up to hit this x-intercept, and then after it hit that x-intercept, it just kind of kept on going up forever and ever. Okay? Now, this is just a general sketch. Like I said, nothing accurate. As you can tell, like I'm drawing this thing on a pen and tablet. It looks horrible, but what I have is the general shape and the x-intercepts, and that's really all I need. So let me show you where the end behavior is. All right, so when we talk about end behavior of a graph, what that means is when we go off to the right, and I look at the right-hand side of this graph, the end behavior is whatever the graph is doing on the end of the right-hand side. Okay, so we're looking at this part of the graph, the end on the right-hand side. Okay, and the same thing, I can go off to the left, right? So as I go off this direction towards the left, I look at what my function is doing on the left-hand side. So I'm looking at this piece of the function here. Okay, so those parts that I have highlighted, that is what we call the end behavior. So as I go off to the right, is it going up or is it going down? And as I go off to the left, is it going up or is it going down? So for our polynomial, as we go off to the left, our polynomial is going down. Okay, so when I describe the end behavior, I'm just going to come over here and I'm going to draw an arrow that says down. And then as I go off to the right, this thing is going up. Right, so over here, I'm going to put a second arrow for the right-hand side of the polynomial, and I'm going to say on the right-hand side, it's going up. On the left-hand side, it's going down. Okay, and we're going to come up with a more formal way to state the end behavior later on, but for now, I just want you to focus on drawing those ends here in the box, right? So just give me some arrows that tell me what it does on the left-hand side and what it does on the right-hand side. So this one goes down, up, okay? There is a lot of squiggly stuff that happens in the middle, but when we talk about end behavior, we're only concerned about these ends, okay? So let's take a look at this next polynomial here. You'll notice the only difference between these two is that I put a negative out front. All right, so when we fill in this information, the only thing that's going to change here is the leading coefficient. Instead of being positive, it's now negative, but the degree is still going to be odd. How is that going to affect my end behavior? So I'm going to go back to my Desmos graph, and you'll notice I've already got the function entered in here with the negative out front, and I'm going to go ahead and turn that graph on. So remember, the blue function was before I put in the negative, and this new function is going to be after I put this negative in here. So let's see what it does. All right, so there it is, right? So the green function is with the negative, and you notice a reflection occurs here. It reflects across the x-axis, but let's look at the ends, okay? So remember, the ends are these guys over here. So as I go to the left, this thing is going up, okay? And as I go to the right, the green polynomial is going down, all right? So as I go to the left, it goes up. As I go to the right, it goes down. All right, so let's go back to our notes here. So as I went to the left, I forgot already. As I went to the left, this thing was going up, right? So I'm going to draw on the left side here, I'm going to draw an up arrow. And then as we went to the right, it went down. So putting that negative in front of that polynomial flipped my end behavior, okay? All right, let's look at a new one. Let's jump over to this one. This one is in standard form, all right, and we'll look for the leading coefficient first. So for the leading coefficient, I've got to go to the highest degree term. That's going to be this x to the fourth here, and the number in front, since I don't see anything, it is a 1, right, and it's a positive 1, so the leading coefficient is positive. Then I'm going to assess the degree. So remember, the degree is the highest exponent that we see when it's in that standard form. So 2, 3, there's an exponent of 4, so that tells me this is a degree 4, and 4 is even. Okay, so remember, to determine end behavior, we're not really concerned about what the leading coefficient actually is or what the degree actually is. We're just concerned about whether or not it's positive or negative, even or odd. Okay, so this is different from the first two in that we have an even polynomial instead of an odd polynomial. So I'm going to go to my graph. I'm going to check out this end behavior on the graph and see what we get. All right, so you'll notice I already had it entered in here, so I typed it into Desmos just like this, and I can see the graph. Okay, so this is what it looks like, and I'm going to assess its ends. So I'm going to start by going to the left, right? So as I go to the left, this thing ultimately goes up, right? So in the end here, it's going up. And then same thing, if I go over here and I go off to the right, this polynomial eventually goes up again, okay? So on both ends, we're seeing the polynomial go up, okay? So I'm gonna come over here, I'm gonna say on the left-hand side, it goes up, and on the right-hand side, it goes up, right? So we have an up, up, with a bunch of squiggly stuff that happens in the middle, but we're not concerned about that. We're only concerned about the ends, all right? So and yes, you see a lot of up and downs here in the middle, but ultimately it goes up, and it goes up in both directions. Okay? All right, so let's get this last polynomial here. I'm going to notice that the only difference between these two is I put a negative out front again. So our leading coefficient this time is going to be negative. It's still going to be even because it's a fourth degree polynomial. But I want to see what happens when I change that leading coefficient to negative with the end behavior. All right, so I'm going to come over here. I've already got it plotted, or I've already got it typed in, so I'm just going to go ahead and turn it on, and you'll see that green function appear. That's with the negative, and you'll see, again, we get a reflection over the x-axis, right? So as I go to the left, the green function is going down. And as I go to the right, the green function is going down. Okay, so we end up with a down, down polynomial. Bunch of squiggly stuff in the middle, but the ends are both going down. Okay, so as it turns out, we can use this pattern that we see here to tell us about any polynomial that we might encounter. If I ever get a polynomial that is positive, that has a positive leading coefficient and an odd degree, it will always be down, up. If I get a polynomial that has a negative leading coefficient with an odd degree, it will always be up, down. Okay? If I ever get a polynomial that is positive and even, it'll always be up, up. And then if I ever get a polynomial that's got a negative leading coefficient and an even degree, it'll always be down, down. All right, so just go ahead and flip over to the next page. There is a table here to kind of help you remember this. Remember, even degree, positive leading coefficient. We saw in our experiment that that created an up, up, and it'll do it for every polynomial with those characteristics. Okay. When we had an even negative, it created a polynomial that had a down, down end behavior, and that'll be true of any polynomial that is even degree negative leading coefficient. Okay. When we saw an odd degree positive leading coefficient polynomial, we saw a down, up end behavior, and that'll be true of all of them. And then same thing, or not the same thing here, but when we saw a polynomial that was odd with a negative leading coefficient, that created an up, down end behavior. Okay, and that'll be true for all polynomials that are odd and negative. Okay, all right, we're going to stop the recording there. I'm going to let you guys do some practice problems with that end behavior stuff and post in the discussion forum for today for discussion 4. All right, guys, thank you very much. Have a good day.